of mine. I don't know if you had this genius plan to combine us two, but I think what we both want to tell you fits exactly together. It's about how making science education relevant in the sense of the title of this conference. And this relevance means two things: making science education relevant for the society, giving young people all the competencies they will need to create this 21st century future and facing all the challenges that they have. And the second sense of relevance can be understood in the sense of lesson relevance, giving the students relevant lessons, giving them a sense of science that makes science for them valuable. They think, okay, there's a need of science to solve those problems I see in my surrounding. So this relevance can be seen in two senses. And inquiry-based science education is an excellent framework for this. And as I suspected, we all have the same problems. Science teachers are quite well in this hypothesis and they are quite well in these answers. But giving the students an insight about this process of data collection and interpretation of data and connecting the problem with the answers, there is a lack of methods. There are not many educational contexts that we are used to give the children to get these phases done. And what I'm going to tell you about, is citizen science as a method to support ESD. You must know I'm not only a lecturer at University of Klagenfurt, I'm also the head of a science education center, which is a kind of intermediate institution that helps schools to do some outdoor projects and connect schools to scientists. And citizen science, can we go to the next slide, please? Citizen science, it's okay. It's a concept we found several years ago. Citizen science projects are quite popular in Austria at this time. And citizen science means that real scientists, biologists, chemists, and so on, involve amateurs, people from the society, to help them in their scientific projects. And this has two effects. One effect is that normal people may have some other insights than the scientist that is doing his way. And the other effect is you enable a dialogue between science and society, and people understand why science is so important to solve problems of society, and they see how science works and they value science more when they get involved to a science project. And what we are doing is doing citizen science project with schools. We combine school children to real scientists, and the children help the scientists to do their research work, help them collecting data, help them interpreting, and it has a lot of effects. It improves the competencies of the children in scientific work as they get all phases of the inquiry circle. It promotes their appreciation of research and innovation as they see, oh, scientists really contribute something to our society. It provides meaningful contexts for science learnings. For a child that gets to know why do I have to know something about formula, about acoustics? If they have a project where this is needed, they say, science is important to everyday life. And it gives the kids an authentic insight into the occupation of a scientist. So if a small boy meets a real scientist, he may think, oh, I could become a scientist too. I understand what this work is like. So I have just a short time, so I prepared two examples, one for primary school, one for more classes. to show how this could work. Slide. The first project is the Squirrel Project. It's for younger children, 7 to 10 years. It's a quite short project. The context is we have a big city park and a big green yard in our city. And in this city park, we used to have big populations of squirrels. And due to environmental problems and so, there was the idea, okay, maybe the number of the squirrels decreased and we don't know where they live and what are the conditions. So a consulting office for ecology was called by the city to do research on the squirrel population. Where do the squirrels live? How many are there? And we involved schools, 3rd and 4th graders, primary school children. We involved a scout group and different science education institutions. And the kids got workshops about squirrels. They got introduced in the research questions. And then we got them together with the real biologists, ecologists, and they showed them how a real ecologist does a monitoring study for some animals. How to find them, how to document it. And the kids did together with the researchers this outdoor research. They counted the animals, they made photographs of it, they found out where the places are, where they live and where they live not more, and did the discussion to follow up the results. And we are very proud, as you see in this blue page of the city newspaper, the children and the researchers presented to the city the results of their research. And one result was that there were too little conifers, as the squirrels need the seeds of the conifers to eat. And the city planted more conifers in the city center, so the children saw their research had a result, it had a meaning, and they found out how to improve the environment. So, next slide. Keep Moving was a big project in a small rural area where public transport is not so good, where the traffic conditions are not so good. And we did for a whole year with all schools in this area this citizen science project. In this area we have a university for applied science that focuses on infrastructure and mobility research. And we put together kindergarten classes, primary school classes, secondary school classes, the local authorities, the regional transport enterprises, and enterprises of vehicle production. And we did a whole year's project on transport topics, beginning from how a motor works, how dangerous and poisonous are the gases that come out, and what is it with velocity, and how is traffic safety. So a lot of topics connected to the curriculum. Next slide, please. And the kids got workshops as well in school, but also were involved into Authentic's method of mobility research. They did questionnaires with the passengers of the public transport. They did mappings of the safe ways to cross the streets. They did velocity measuring. They did noise measuring. They tried to find out where are the points in our region that are real problems in traffic. And we did this in age group adapted formats for the little ones with puppets and with people in costumes finding the safest way to the railway station and so on. But they really got valid data as the scientists were involved, and they identified real problems. Next slide. And we had a huge follow-up where the mayor came, the responsible persons of the traffic enterprises came, the developers of the vehicles came, and the children presented their research and made suggestions how to improve the mobility situation in this area. And they had to argument with their research, their findings, their interpretations, and one real effect was that at once, for example, the children found out there was no safe bus station near the school and no bus station with a roof on it when it rains. And the mayor said, oh, good idea. Nobody found this out until now, until the children said this, and the city built this station here, a safe traffic station, and the research of the kids really had an effect. So, the time I think is over, but if you want to know more, ask me please. Thanks for your attention.
Okay, thank you, Dr. Andrea. Please give applause for her. Okay, there is Q&A session. There is any question from the audience? Okay. Thank you.
Okay, hello, Dr. Andrea. My name is Utu. It was a very, very interesting what you have present. I have a concern. So I tried to do this kind of teaching, like ESD. Like I really, really love to teach students about sustainability. I want them to have a good sustainability awareness. But the problem is what happened in my class. They know what best for the earth. They know how to do better and what sorry. Yeah, and they know what's better for the earth, but they still think that they can't do anything about that. They just know they know what better for the earth. They know what kind of things they need to do, but inside they still think that they can't do anything about the condition, and I'm so concerned that it will decrease their sustainability awareness. Sorry. And so it was so interesting that you have that citizen science. Is it really like I want you to give some advice to me, like what I need to do to my students, how so they have increased their interest in doing, like ESD, like so they can feel that what they do, what they think, and what's happen inside their brain, it matters to the earth. Maybe that's.
It's a very good question. I also experienced several times that these big sustainability problems are far too much for small children. How should they save the rainforest in South America also? So what I'm going to do is pick some very local solvable problems. For example, this squirrel project to plant some more conifers that the squirrels have the food and do this research-based is a problem that can be solved, and which gives the children motivation that their work, that their engagement counts. And as you saw, they brought it in the newspaper, which was really motivating for the children. I think it's good to find local problems and be in contact with your local authorities. That's, I think, it was really hard work to establish this science education center, but we are in strong contact to our city authorities. And they tell us what are problems in our city. For example, we had problems with loud parties of teenagers in the city park, So we did something about acoustics and so. So we have real problems, and we have problems that are relevant for the local people, and the children can see the effect of their research and their solution. So my advice is pick very small topics, to grow a school garden, to do more greening in your area, or do something that's in direct effect of your surrounding. They can't solve the big problems, but they can do small steps, and it is very important that they get valued for their work. So the collaboration with local authorities, the collaboration with science people, it's a big motivation for your work. And the second advice I give you is it's often difficult if you do a lot of project work to transport this to parents, grandparents, headmaster, and so on. We strictly connect curriculum contents to this work. So if we do this acoustic workshop, we can tell the parents, look, this is written there, and we do this project, and the children learn these competencies during this project. So you can find arguments why this ESD work is not something you do for fun instead of teaching what you should teach them, but as a good method to fulfill the curriculum in a relevant way. So those are my advices.
Thank you.
Thank you. Have feedback?
And no,
Enough?
thank you. Thank you.
Okay.
Yeah, of course.
Thank you.
Thank you.
There is any other question? Okay.
Okay, thank you. Thank you very much. Very amazing presentation. Very amazing topic. Very good. Thank you very much. Okay, I have two questions. Number one, the term, citizen science. Before this, we call it the scientific society. So now we have another term, citizen science. Is there any differences between scientific society and citizen science? Question number one. I have another question. The second question is, this is very good. How we cultivate our children, our young generation become citizen science. Could you explain a little bit about how to assess? Because after we go to this kind methods of teaching and learning, to the students, then how we want to make the assessment must be different with traditional assessments. Nowadays our evaluation is very exam oriented, for example. But now when citizen science, must be changes to the assessment method. Maybe you can give us the explanation about that. Thank you very much.
I hope it works. I think it's a slide because of a whole scientific society that appreciates science, sees it as a vehicle to create a good future. Citizen science is more the term for the practical work, for involving the citizen into science. It's almost something with adults, helping ornithologists and so on. But this is a common term for the very practical work doing in research. As in contrary, the scientific society means more the mindset of a society towards science, and citizen science refers to the practical work. And the second question concerning the assessment, it's not necessarily totally different if you refer to the curriculum. So if you have your test as before, how does a scientist work, how many teeth does their squirrel have, you can use this as a quite average teaching method, because after these projects you can do the same test as before if you have to do, which I want to do because you have much more in this. One method for assessment could be a portfolio method, for example, where children do their research diaries, document like a scientist, what have they done, what was my research question, what are my results, what is my interpretation. So this a more near to science created way of assessment would, in my opinion, fit better to this project. But if this is not possible, if you create good connections to the curriculum, you can do your average test also.
Did you really give feedback?
Yes, excellent.
Okay, I was sure that you still have a bunch of questions for Dr. Andrea, but time is up. Let me give a bigger round of applause for her. Oh, yes, please.
Satu keliling dia ke semua ruangan. Satu untuk semua ini baru.